Hi, hello everyone. Myself Nitin with my friend Vivek Jain, Reni Chaplot, and yogendra Singh Solanki. Now we are going to discuss on the topic oscillators. We everyone very well known that about the oscillator, which is the heart of the analog electronics devices. Oscillator is a kind of circuitry in which we uh, have no need to give any input in that circuit and provide an output waveforms. Fine. There are some definitions also here. That is, what do you mean by oscillators in different aspects? So, oscillator, an effect that repeatedly and regularly fluctuate about the mean value, and an oscillator circuit that produce oscillations and characteristics of wave shapes, frequency, and amplitude distortion, uh, stability. Now, I have previously introduced about what do you mean by oscillator. There are many kinds of oscillator. Here we are discussing about the linear oscillators, where the wind bridge oscillator, RC phase shift oscillator, and LC oscillators are preferable. And all the oscillators are based on the stability criteria. The oscillator which have highest stability, we can use that kind of oscillator. Application of oscillators are used to generate signal. Example, use as a local oscillator to transfer the RF signal to IF signal in a receiver, used to generate RF carrier in a transmitter, used to generate clock in digital system, and used as a sweep circuit in the TV set and the CROs. Now these are the linear oscillators: is band bridge oscillator, RC phase shift oscillator, and LC types of oscillators. The basic concept behind the oscillation is the feedback path. The oscillator always needed a positive feedback. Similarly, for a sinusoidal input is connected linearly because the output is approximately simultaneous uh, sinusoidal. A linear oscillator contains two conditions: a frequency selection, feedback network, and amplifier to maintain the loop gain at a unity level. Now, the basic linear oscillator principle is that this equation denotes the output divided by input. Input source is mix up of the feedback with the input, and then the finally output is goes to the amplifier, and the output was in a positive term, so we have a positive feedback gain. V output divided by Vs is equal to A upon 1 minus of A beta. For the oscillations, there are basic principle is derived by the Vargas creation. A beta should be equal to 1 and greater than equal to 1 for the sustained oscillation condition. Now we are not dealing with the whole circuit in this scenario. Here we are going to discuss with the band bridge oscillator. In band bridge oscillator, the RC type of section is used in feedback path, and here the x1 and x2 are the two reactive component. So z1 is denoted by 1 upon omega c1 and z2 is denoted by 1 upon omega c2. So finally we have to calculate in whole equation is that a and beta. So beta is equal to, in case of wind bridge oscillator, beta is equal to r2 x c2 x1 x2 divided by this equation with the imaginary part. And for the frequency we normally put the imaginary part is equal to 0, and for the sustained oscillation condition we normally put the positive part or real part equal to 0 to get the sustained condition. This is the wind bridge oscillator final oscillation condition. Omega is equal to 1 upon 2 pi RC and omega is equal to 2 pi FC if we put. So finally frequency F is equal to 1 upon 2 pi RC and imaginary part is equal to 0. So beta is equal to 1:3 ratio in the case of wind bridge oscillator. Similarly, the RC phase shift oscillator, it consists the R and C section at the feedback path and use an inverting amplifier mode. The additional 180-degree phase shift is provided by the amplifier and the 180-degree phase shift provided by rest feedback path. So total phase shift around a loop is 0 degree or 360 degree, which satisfied the condition of Barkhausen creation. Here we are going to apply the KVL at the output port, or we can say in the feedback part. We have a three general equations, and finally solving the current I1, I2 and I3, we get this types of equation, and finally we get V output. And our motive is to calculate the beta and omega. So beta is the feedback factor. Noted that this is not a amplification gain, this is a feedback factor. Okay, so beta is equal to V output divided by V1. So omega frequency is equal to 1 upon under root of 6 RC, and beta is equal to 1 upon minus 1 upon 29. The negative sign means that the phase inversion from the voltage. Now we are moving from LRC oscillators. In terms of LC oscillator, there are few advantages with respect to RC, and there are few disadvantages with respect to LC oscillators. Now normally the LC oscillators are based on two types. Here we discussing on the Colpitts oscillator and Hartley oscillator. The basic principle is same as the Barkhasen creation stated. Here whole calculation is done similarly way. This one is the feedback section, and this is your amplification factor. When the loop around 360 degree or 0 degree phase shift, we get finally the oscillated output in a sustained manner, and the gain A is equal to V output divided by V input. So after solving this equivalent circuit, we get the final solution. These are after solving putting the imaginary part and real part is equal to 0, we get for the unity gain and the 180 degree phase shift. This is the Hartley oscillator circuit diagram, and here we discuss Colpitts oscillator. Similarly, Colpitts oscillator, here we are taking the feedback, two capacitors and one inductor. By varying the capacitance value and the inductor L value, we can change our frequency level up to a megahertz ranges. Fine. If we select lower value, then our component size will be definitely increase. The frequency stability of an oscillation is defined as 1 upon omega del of dw divided by dt. Omega is equal to omega naught. Use high stability capacitor, example silver, mica, Teflon capacitors, and low temperature coefficient inductors for high stable oscillations. The amplitude stability, in order to start the oscillation, the loop gain must be equal to greater than equal to 1, and the LC oscillators generally do not require amplitude stabilization circuit because of the selectivity of the LC circuits. In RC oscillators, some non-linear devices, example negative temperature coefficient and positive temperature coefficient resistance, JFET or Zener diode, can be used to stabilize the amplitude. So finally we have conclude that we have learnt about what oscillator is exactly, and what types of oscillators there are, LC and RC types of oscillator. Fine, and thank you.